Second form of A representing a straight line is a pair of planes. Two non-parallel planes are given. That two non-parallel planes, points of intersection, that is the common part will be a straight line. Suppose the plane is a1x plus b1y plus c1z plus d1 is equal to 0. That is exactly this plane. This is one of the plane. That plane is p1. And whose normal to that plane is a1, b1, c1 are its direction ratios. So a1, b1, c1 are the direction ratios of that normal to that plane. And the second plane is a2x plus b2y plus c2z plus d2 is equal to 0. That second plane is like this. Now these two planes are intersecting along this line. And this second plane, normal DRs are nothing but A2, B2, C2. Now, this is the common part of that two planes. That is the common line of these two planes. This is the intersection of the two planes is exactly the line which we are talking about here. So this line, you can observe that this line will be parallel to cross product of these two normals. This is the normal to the second plane. This is the normal to the first plane. These two normals cross product will be parallel to line of intersection of the two planes. That is what. Therefore, when we calculate the cross product of these two normals, that is ijk, a1, b1, c1, a2, b2, c2, when we expand this cross product, that is b1, c2 minus b2, c1, I, minus a1, c2 minus a2, c1, j, plus a1, b2 minus a2, b1, k, then its coefficients are nothing but drs of the common line, that is b1, c2 minus b2, c1. And here this minus sign, I send it inside. This would become c1, a2 minus c2, a1. And the next one is a1, b2 minus a2, b1. These are the drs of common line of these two planes. The plane in the midway between parallel planes. One plane is ax plus by plus cz plus d1 is equal to 0. And the other plane is ax plus by plus cz plus d2 is equal to 0. Children, you observe here x, y, z coefficients are the same here. That two planes differs only in the constant d1 and d2. They are, both of them are perfectly parallel planes. Then you can imagine one plane exactly in between them, in the middle of it. That plane equation will be ax plus by plus cz plus average value of the two constants d1 and d2. That is d1 plus d2 by 2. If q, l comma m comma n be foot of the perpendicular of px1 y1 z1 on this plane ax plus by plus cz plus d is equal to 0. In 2D geometry, if h comma k is the foot of the perpendicular of x1 y1 on the ax plus by plus c is equal to 0, we have remembered that h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. That same formula imitation here, that is L minus x1 by a is equal to m minus y1 by b is equal to n minus z1 by c is equal to minus of ax1 plus by1 plus cz1 plus d by a square plus b square plus c square. From this equation, if you solve for L, m and n, that exactly becomes the foot of the perpendicular of this point px1 y1 z1 on this plane. So this is the plane here. This is the point px1 y1 z1. Perpendicular is drawn. This is the foot of the perpendicular L, m, n. Now we know that this is the normal drs of the plane are x, y, z coefficients. They are the ABCs. Now you can observe this. This line joining PQ is parallel to the normal to that plane. Once they are normal, then the drs of PQ are nothing but L minus x1, m minus y1, n minus z1, which are parallel to ABC, means DRs must be in proportion. That is L minus X1 by A is equal to M minus Y1 by B is equal to N minus Z1 by C. You assume this is equal to T. From here, write the LMN coordinates. Here the L is nothing but AT plus X1. That is X1 plus AT. That is AT plus X1. M is BT plus Y1. N is CT plus Z1. Now this point QLMN is supposed to lie on this plane equation. Means this LMN are substituted in this plane. Once we substituted lies on this plane, then A into AT plus X1 plus B into BT plus Y1 plus C into CT plus Z1 plus D is equal to 0. From here T will be minus of AX1 plus BY1 plus CZ1 plus D by A square plus B square plus C square. This T value, once you put it here, then this equation is exactly the equation this we are searching for. So this equation, foot of the perpendicular, formula derivation is given now.